Welcome to Unit 2 on Risk Perception. This is the first of 3 units that focus on the behavioural sciences area of risk analysis. The 3 parts are risk perception, risk communication, and the social amplification of risk. Our agenda is as follows. Introduction to risk analysis from behavioural sciences, the 3-part component of risk perception today, risk communication, Unit 3, and social amplification of risk, Unit 4. Second, we look at perceived versus actual number of fatalities. Third, overlapping fields between risk analysis and political risk analysis. Fourth, what risk analysis is and is not. Fifth, the evolution of the field of the risk analysis. Then we look at the risk perception matrix. And finally, the affect heuristic. First, I want to illustrate how the fields of political risk analysis and risk analysis, the latter from the behavioural sciences, link together. You will see from this Venn diagram that both fields have developed independently of each other. However, they do overlap in that risk analysis from the behavioural sciences can provide political risk analysis with valuable frameworks and approaches to better understand how stakeholders perceive risks of events that potentially or actually harm the well-being of individuals. Given its strong academic research base that includes extensive empirical studies, this makes for a great area to look at. The field of risk analysis stems from behavioural and decision sciences. It is good for understanding risks, perceived or actual, that potentially cause harm to individuals and those around them. It is not suitable for understanding risks of financial decisions, expropriations and demographic changes, for example. It is also not public relations. The risk analysis developed separately to political risk analysis, but is now overlapping. It's important to us because the failure for companies and government departments to get risk analysis right can cost them lots of money, through either loss of sales or litigation, and potentially cost lives and impact health. For example, Fukushima, fracking, genetically modified foods, and the mumps and measles rubella vaccine. The private and public sector unfortunately all too often get it wrong. Public outcry from new technologies in the 1970s and technological mishaps, e.g. chemical and nuclear plants, helped to facilitate risk perception research to measure individual perceptions of risk and judgments associated with risk-related options. All publics worry more about involuntary and unfamiliar risks than voluntary and familiar risks. This slide shows the estimated number of deaths per year from risks and the actual number of deaths per year. You'll see how the public in the US can overestimate the number of fatalities from rare events like botulism, 900 perceived deaths per year versus 10, and underestimate more common risks like heart disease, around 12,000 per year versus 1 million. Take a look at how the other risks are plotted. We can take this a next stage further by plotting perceived risks on a grid. This is called a risk perception matrix, also referred to as the psychometric paradigm, to understand why people perceive hazards differently. The risk perception research that developed the risk matrix, emanated from the work of Slovic, Fischoff and Lichtenstein, first published in the 1970s and 1980s. The risk matrix assumes that risk is subjectively defined by individuals, who are influenced by a wide array of psychological, social, institutional and cultural factors. Perceived hazards and risks, as defined by the public, can be plotted on the grid with an x-axis from non-dread to dread risks, left to right, and y-axis from known to unknown risks, bottom to top. Non-dread risks are those perceived to be more controllable, low risk to future generations, and not affecting themselves, e.g. familiar items like using home appliances. Dread risks are those seen as uncontrollable, high risk to future generations and involuntary, e.g. nuclear weapons. The y-axis has unknown risk, which is not observable, unknown to those exposed, and the effects of it are delayed, e.g. nitrates or carcinogenic compounds. Known risk is observable, old risks and risks known to science, like driving a car. Despite the defined categories, the matrix is an approximation of a complex reality, one that varies by gender, age, experience, and recent history. Because an aggregated approach is taken, the paradigm has been critiqued for overlooking individual differences of risk perception. But it is useful to provide an approximation and the basis of discussion to better understand the perceived risks of an event. Next, we turn to the affect heuristic. The term affect heuristic is used to explain how people make decisions based on what they have previously experienced and how they analyze the situation. Understanding the affect heuristic is critical for three reasons. Risk perception research on affect heuristic has identified that people make judgments using two approaches. First, the experiential. Individuals recall prior experiences and recollected images from first-hand or media reporting of a risk, which influences perceived feelings, goodness or badness, about a risk or an event. Second, the analytical. Individuals analyze the risk to inform their judgment. Research on the affect heuristic found that when people make decisions, the experiential precedes the analytical. Strong emotional experiences related to hazards may increase public's perceptions of risks. For example, if you mention terrorism, the first thing that individuals may think of is the September 11th attacks and the World Trade Center being hit, rather than analysing the probability of terrorism impacting them. This slide shows how perceived benefit and risk can impact the other. For example, for nuclear power, A shows that information saying nuclear power is beneficial will probably mean people will see the risk as low. B shows that if risk is communicated as low, then the benefit will be seen high. However, if, as shown in C, the benefit is shown as low, then a risk may be seen as high. And finally, high risk results in low benefit. A number of studies have replicated this pattern. Of course, there are other aspects like events themselves, e.g. nuclear accidents, that can impact perceptions. But information on its own in studies has proven a strong correlation between perceived risk and benefit. This aspect is also useful when we move onto our risk communication section in the next unit. Well, that wraps up the risk perception unit. Thank you for your time.